Good morning and good afternoon, everyone. Thanks for joining. I'm going to start with sharing my screen and we can carry on with the webinar. All right, fantastic. I hope you can now see my screen. Beautiful. Good morning and good afternoon. My name is Puya Gabazi. I'm the Senior Solution Engineer at Autodesk. And in today's session, I would like to introduce you to the challenges that we face in the manufacturing industry in terms of designing our factory, and introduce you to the technologies that Autodesk provides to our customers to address those challenges and address those issues that we face in terms of manual works. How do we automate it? How do we avoid costly mistakes and errors early on in the process? On the first slide, I'll put there's a QR code. This will take you to my LinkedIn page if you would like to connect with me directly later on. If you have any questions, feel free to raise it in the Q&A tab. We will do our best to address your questions. After the session, you can either directly contact myself or reach out to our team members at Archons. Without any further ado, let's get started. Now, the focus of the session again is on factory design, but we know that factories have been around for centuries, and they have come a long way in the previous century. Not just how they operate, but the whole process of how they are developed has changed significantly. Although we have made significant improvements in factory modeling, there is still opportunity to advance in this process. Despite all changes and improvements, even today, there are many manual, disconnected, and paper-based processes that are keeping us from achieving our factory modeling goals. What we see on the screen here is the reality of many manufacturers and many businesses. We are already stretched to the breaking point. People spend too much time on manually managing information, tasks, processes, and decisions that could be automated, working with multiple data formats from incompatible systems, trying to overcome the multiple silos that exist in the business, trying to connect a mix of digital and analog data. So the main question our customers are asking is simply, where should I start to address these changes? But these changes go beyond this. The other challenge that clients are facing is that the chaos that we witness is not just within the organization itself. It continues across the supply chain, affecting the overall operational efficiency and time to market. What manufacturers are trying to achieve is continual unhindered project progress and delivery. But in reality, many factory owners and operators are focused to develop their facilities with disconnected workflows. This needs manual handoff between each stage, leading to longer delivery time and higher costs. Let's have a quick overview of the digital factory lifecycle, which is the goal of the presentation today. We want to digitize this process. There are four main stages of the digital factory lifecycle: plan, design, build, and operate. Each of these stages have their own specific challenges. The planning is where we formulate the approach, define the purposes, constraints, scopes of the project, and that's where we set targets. Design is about working out how we're going to realize our plans and objectives in an optimal way, surrounding both the factory and the building itself. Then the build process is where we implement these designs, constructing the factory building and internal production facilities. And finally, operate is where we focus on optimizing effective manufacturing throughput to meet our manufacturing targets. These four main stages of planning, designing, and building and operating are actually connected together, with decisions at one stage often having unintended consequences at the next phase, at the next step. The more seamlessly they are connected, the more efficient and effective the whole development and operation is going to be. When constructing and developing digital factory, we see and we hear that the customers are going from the left side of the screen to what we have on the right side of the screen, going from analog systems to automated ones, replacing fragmented and broken workflows to standardized best practices, avoiding siloed informations, making it shared and validated and available and validated to others, evolving stagnant processes to innovative ones, and finally move away from high-waste situations to agile and lean situations. In factory planning, a wide variety of trades must be coordinated, and all participants must be supplied with the latest data. This includes production planning, technical building equipment, which could be the ventilation, lighting, water piping, electricity wiring, and so on, and building design. Autodesk enables you to bring the data and design related to each stakeholder in one environment and combine all of those designs, all of those models all together. This enables our users to detect errors early on in the design and planning phase and avoid costly mistakes. So let's go through these phases. Let's go through in a specific the plan, design, and validation phases and see how Autodesk can assist you in combining the data related to these phases. Let's start with the planning phase. Planning starts with the land or site development. Different types of plannings include site development planning, process planning like the manufacturing sequencing, or it could be product lifecycle planning, and also planning for the building itself, the building that you're going to place within that site. We can utilize, in this case, to address this challenge, we can utilize Autodesk InfraWorks to address the challenges associated with the planning phase. Let's say you have a plot area where you want to create the concept layout of your factory. This is where you can extract the longitude and latitudes of your site simply from Google Maps, insert it into Autodesk InfraWorks, and start building and developing your plan within InfraWorks quite seamlessly. Using Autodesk InfraWorks, you can define the utilization of the area, determine where the roads are going to be, design the infrastructure, and the layout of your buildings. Let's look at this in action. Using InfraWorks, you'll be able to gather the site area and mark the coordinations, as well as boundary of the site. Let's say you have a building like what we have here. You have a building design that was created by another team. You can bring those models, in this case, designed in Revit, simply bring them into InfraWorks, and then start developing, in this example, the road layout. We have a library. Simply from the library, you can select the type of road you want. You can see how we can define the road itself, connecting our factory to the main road. And by doing this, it will take into consideration the banking, the ground slope, and everything else for us. And then from there, you can seamlessly conduct a cut fill analysis within InfraWorks. But how about process planning? Industrial process planning includes the systematic design or organization of production processes to ensure efficiency and quality. It also includes defining workflows, selecting appropriate machinery and technologies, and optimizing resource allocation. Currently, users are doing this planning process through manual and disconnected tools like spreadsheets, flowcharts, and so on. But this is resulting in errors and challenges to accurately manage the cost, to accurately manage the risks and downtimes, and to accurately calculate the long-term impact of the changes that we want to apply to our factories. So how can we optimize our factories to address these issues? This is where Autodesk FlexSim can address your challenges. FlexSim is a tool that simulates the flow of all resources and processes, including manufacturing, material handling, and even logistics, and even people in the factory. Customers can use FlexSim for a multitude of reasons, including identifying bottlenecks, validating new layouts and processes, and optimizing production processes. This helps support outcomes such as increasing manufacturing throughput, reducing resource consumption, and of course, improving profitability for your manufacturing facility. Now let's take a quick look at FlexSim in action.
FlexSim is an object-oriented 3D simulation software that handles both discrete event and continuous simulation. It allows you to model any type of sequential flow or factory operation. If you manufacture products, build assemblies, or have warehouse or supply chain operations, FlexSim is the simulation product for you. FlexSim is used to eliminate waste in a production process, with waste being any action that doesn't add value to the customer. Waiting adds no value to the customer, and it's expensive to have excess waiting time for customers, products, and machines. FlexSim is a 3D simulation environment, so you can start with an AutoCAD file of the facility and drag out the resources for a true-to-scale model layout. The software also features a script-free logic building environment called Process Flow to help you describe even the most complex processes. This combination of drag-and-drop 3D technology and innovative logic building allows a user to model any system quickly and efficiently. Then bring your real-world data into FlexSim directly from Excel, a database, or an HTTP server using the latest available data to make accurate predictions about future production.
Fantastic. Let's take a look at the next phase, which is design. Design phase can be broken down into three sectors: designing the 2D layouts and converting those 2D layouts into 3D models, which is developing the 2D layout in AutoCAD and then automatically being able to synchronize it with your 3D models, let's say in Inventor and Revit and so on. Next is supplier integration. When you receive machinery from your vendors and suppliers, you will need to be able to integrate them into your factory while avoiding clashes either between the equipments themselves or between the equipment and the factory facility that you have. And finally, making sure your factory is sustainable in nature. For the most part, layouts are still created in 2D. These layouts are usually readable by only professionals with a lot of experience, and of course are error-prone because the third dimension is missing. Also, all accompanying documents like Word, Excel, PDF, and handwritten documents are distributed separately via mail. This can result in a lot of errors due to lack of third dimension and lack of connections with the third-party applications that we just mentioned. Let's consider an example. Of course, AutoCAD is the industry standard for layout tools today. It is a very powerful tool for planning, but it doesn't represent the full manufacturing environment. Real production environments are much more complex. Errors are typically introduced when information is missing, like the vertical dimension, or what needs to move or be removed, or how items will be moved into position. That is where Autodesk is unique in its offering. We have a set of collections named Autodesk Factory Design Utilities, especially designed for factory layouts. By using Factory Design Utility, you can start creating your facilities in 2D using AutoCAD and its library of assets with a series of libraries that are available and pre-built for you. As soon as you start using the assets by placing them inside AutoCAD, the 3D model will be automatically generated as well. While you create the 2D layout, the 3D model is automatically created. You don't have to work exclusively in 2D, you can start modifying the model in 3D, which will also, the connection is bidirectional, which will also modify the 2D model for you automatically. Both 2D and 3D have the same set of libraries and assets that are bidirectionally linked. Let's look at an example. Let me show you an example of how it works. Here in AutoCAD, I'm pulling all the assets I need from my library in AutoCAD to create my desired layout in 2D. In this example, we are setting up a conveyor belt system. You can simply define the path, and AutoCAD will automatically add the corners and determine the correct number of sections for the belts. Now, since these are dynamic assets, you can still modify them as you need, as we can see on the screen. Once your 2D layout is created, you can simply sync the 2D layout with 3D in Inventor by simply selecting Open in Inventor. This will convert your 2D layout to a 3D model, allowing you to continue modifying your layout now in 3D. This will enable you to easily visualize any clashes in your model, maintain an accurate bill of material, and create 3D-based drawings of your layouts. Till now, our presentation was focused on greenfield projects, projects that you don't have a factory and you have to design the factory from scratch. But how about brownfield projects, where you already have a factory and you want to update your factory due to new requirements? This is also applicable when you need to improve the efficiency or output of an existing facility. We also have this scenario covered. In this case, you can simply capture the 3D scan of your facility and insert your scan into Autodesk Recap Pro and convert your point cloud data into a solid model. This will enable you to start creating models upon the 3D model of your facility. Let's have a look at an example where point cloud data has been inserted into Recap. After capturing the point cloud data using the scanners, we can bring it into Recap. And in Recap Pro, you can inspect your facility and convert your scan to a 3D model. And then bring the model in Inventor or Navisworks or even Revit. After inserting the model into Inventor here, you can then start creating additional models in reference to your factory. Once your model is finalized, in Autodesk Navisworks, you can identify if there are any clashes between your scanned facility and the new generated model quite easily and capture a report. After finding the clashes, as we can see in this example, simply go back to your Inventor model and modify your model to avoid the clashes. And this is going to save a lot of time because you're finding these errors early on in the process. We will come back to this in the validation phase, and we will talk more about it. So how can we assist you to validate your factory design before you commission your factory? Let's look into that. Validation can be done in two different phases. One is the complete design review, which can be done through clash detection in Autodesk Navisworks, which we discussed briefly. And the other one is virtual collaboration through our VR-based collaboration tools like Autodesk VRED and Autodesk Workshop XR. Once the entire model is ready, you can collate all the different models provided by various suppliers into a single model in Autodesk Navisworks and conduct walkthroughs and clash detection analysis to find if there are any issues with your factory design. This will enable you to identify errors in the earliest stages and avoid costly mistakes. Mistakes like what we can see here on the screen. Autodesk platform allows you to collate models in Navisworks from multiple sources, conduct clash detection, and avoid collision between the structures, pathways, equipment, and so on. And all of this is going to be done in the validation phase, very, very early in your process. Let's have a look at an example, another example. Here we have an example in which we have imported our factory's building, the structure and the equipment all into Navisworks. In Navisworks, we can then conduct a walkthrough to inspect the full model. You can also apply markups and create reports if you come across an issue, all within Navisworks. From here, then like the issue that we are seeing here, simply mark it up. From here, you can go back to Inventor or Revit and apply the required changes. While Navisworks is a tool for managing clashes and conducting reviews, we also have virtual reality-based tools where you can include multiple subcontractors, your clients, or even your team members to perform a virtual review of your entire design. Let's look into that. Here we have taken our Navisworks model into our virtual reality platform, Autodesk Workshop XR, a cloud-based virtual reality tool that enables us to conduct walkthroughs, create markups, and conduct reviews. In this example, we can see the user has identified an item that needs to be changed. They simply mark it up and create a markup in the platform, which will notify the other users in Workshop XR. The notification can also be sent through Autodesk Docs for users, for other users, to apply the required changes. You might also need to conduct a CFD analysis on your facility. This is where Autodesk CFD can offer you the required tools to analyze wind, heat, airflow, and etc. Autodesk CFD offers interoperability with other Autodesk tools like Inventor and Revit, enabling you to simulate not only your equipment, but also your entire factory. Conduct analysis such as the smoke detection, air ventilation, wind analysis, pollution analysis, and more. While going through your factory design process, we are obviously creating a lot of data that needs to be securely managed and stored. We need to securely manage all the assets, provide access to these assets to authorized users, and manage the history of all modifications applied to layouts and equipment. That's where Autodesk Vault comes in. Autodesk Vault is Autodesk Enterprise Document Management System, which can manage your files as well as the entire asset libraries and layouts of your factory. Vault will also enable you to ensure your models, to securely store your models and securely reuse your models. For example, if there is a sub-layout of your factory that you would like to use for another project, Vault enables you to reuse that sub-layout without causing any errors. Let's look at Vault in action. From Inventor, it is possible to switch directly to Vault via the Vault browser. The overall layout and the Vault factory layout are displayed via the Part Usage tab, simply accessible in the Vault interface. Then from there, the Go-To tab can take you directly and quickly to the factory area. There, all used sub-layouts and all factory objects are displayed with their key parameters. In the factory configuration, the object area is defined. One or more folders can be specified in which the objects are subsequently stored. Now, in Inventor and AutoCAD, these folders are displayed as part of your asset library and quite easily accessible for you to reuse. Now, let's have a look at a couple of examples of customers who have actually utilized our tools. Customers who have utilized Autodesk Digital Factory. I'm sure you're all familiar with Porsche. When Porsche opened the factory to support its first fully electric sports car, they planned for a digital factory. The first challenges included the site's location in a hilly urban area. They had to work closely with designers and planners to address every part of the building in advance of the build process itself, and relied heavily on model coordinations and clash detections in the digital platforms that we provided to them. They used a single integrated model that allowed all stakeholders to come together to create the final factory. Porsche even introduced a driverless transport system to move the cars, tools, and equipment within the factory, all created in advance and tested in advance in the virtual reality environment. Building and validating the factory digitally gave Porsche the advantage to improve time to market and generate revenue much sooner. Let's look at another example. Let's hear from Northvolt as they talk about their experiences using a broad range of the Autodesk portfolio, from Revit to architectural design to Inventor, factory design utility to optimize factory operations to Autodesk Construction Cloud for model management. Northvolt is a battery manufacturer that designed and built their entire factory using Autodesk tools. They use tools like Inventor Factory Design Utility for layout, Revit for building, Advanced Steel for civil structure, and so on, and coordinated everything into a single model and created an efficient factory. Let's hear from Northvolt how they made this process work.
What set Northvolt apart from conventional battery manufacturing is this rooted commitment to sustainability in everything we do, from the product design to the recycling approach that ties it all together. The factory is an inorganic organism where every single component needs to work together for this common goal. So we need to think of how can we design and work with the product in parallel with the process and production, with the facility and factory, with construction, commissioning, and just get it all done. Our designs need to account for that.
So we need to build our ecosystem around tools that talk very well together. Data loss is unacceptable. Whatever he's doing, I need to see it. Whatever she's doing, I need to be able to see it and share it with the right people.
Autodesk provides that platform to build this toolbox for us. For the architects, we use Revit. It's very efficient to draw buildings. For more process layouts about placement of machines on floors, we use the factory design utility tools with Inventor, with AutoCAD, with Navis in a Volt PDM environment. For BIM coordination, we use Navisworks to compile everything. For model management and collaboration, we use Autodesk Construction Cloud to really have a cloud-based point of all stakeholders to watch this common model.
So now we're very excited about Autodesk Platform Services, which basically enables us to access many different APIs and tools within the Autodesk ecosystem and put them together in different ways that we want to bridge the gaps between the different tools and make them do almost exactly what we want them to.
We have proven that you can build industry in a new way, that the sustainability mission is not mutually exclusive from being profitable and commercially successful. We have been able to significantly optimize factory design, and we can show with numbers pulled from a live model. Yes, it is cheaper, it is smaller, it is more efficient. That's something I'm very proud of, to have opened that door and opened the mindset to enable the next era of industry.
Fantastic. Well, that brings us to the end of this presentation. I would like to now open the floor for any questions that you guys might have. I'm going to stop sharing my screen. Again, thank you so much for your time listening to my presentation. I'm going to stop sharing my screen and go to the Q&A section. If you have any questions, feel free to post them in the Q&A. And also, you still have the option to reach out to me directly after this webinar, either on LinkedIn or reach out to Archons if you have any questions, I'm sure they will get me engaged to address your questions. I don't see anything posted in the chats or in the Q&A area. I'll take it as we don't have any questions to answer at this stage. Feel free to reach out to us if you need any information about any of the products we talked about: AutoCAD Factory Design Utility, Inventor Factory Design Utility, Navisworks, InfoWorks, how they work together. Again, if you would like to see how that can assist your business, how that can assist you guys to optimize your factory design or improve the efficiency of your factory or increase the output, throughput of your factory, feel free to reach out. More than happy to have another discussion with you guys directly. Again, thank you so much for attending the webinar. Really appreciate it. Hope you have a good day, and we'll catch up with you guys soon, hopefully again. Have a good day. Cheers.